What do you do here at RetroTech?
We sell equipment to test buildings on the air tightness. So we have equipment like this here with the door frame and a fan, and we use it to pressurize the building. And by measuring how much air we blow in, we can measure how much pressure we get. We can also measure how much air is leaking out. So based on this air leaking out, we can find problems with, first of all, energy performance, but apart from that, also issues like mold or condensation problems.
And what do you benefit from doing these tests?
So energy savings is one. So basically, you can heat your house, but if you leave the window open, you're losing a lot of energy. But if you keep the window closed, where there's a big hole somewhere else in the house, it's the same concept as just leaving the window open all the time. So that's one of them. And then apart from that, you would save a lot on maintenance costs as well. So a building that's properly airtight will keep the outside out and the inside in, so you don't have problems with noise coming in, pollution coming in, and you would avoid a lot of issues with mold and condensation within the building itself.
Mold and condensation, you can avoid getting mold in your house by doing these tests.
Correct. So if the warm air from inside travels through your insulation, at some point it will cool off far enough to actually condensate in the wall. And because of that, you get all this moisture in the wall, which would lead to mold and moisture problems.
And how do you prepare for a test like this?
So the preparation for a test like this is mostly in preparing the building itself. So we have to make sure that the external windows and doors are closed, of course. Perhaps you can see we've sealed off the ventilation system, because the ventilation is something that we do not want to measure, as it's controllable. And apart from that, we have all the internal doors open, and there's a whole checklist that we go through to prepare the building. And once that's done, we set up our equipment, we open our software, and we're ready to go.
And can anybody do these tests?
Pretty much. In the end, it's not rocket science, but you'd have to know what you're doing. So a training would be very useful to understand what you're actually doing with this test. And apart from that, the preparation of the building is very important. So if you don't prepare it in a proper way, your results will be far off from the actual results. So it's good to understand what you're actually doing.
And how do you know how tight a house should be?
This depends on the local standards and regulations. So it differs per country, and even within the country it can differ per area. Plus, very often the clients or the owners of the building, they will specify a more stringent regulation than what the local government would give out, for instance. As an example, here in the Netherlands, we have a default value which is 0.6 liter per second per square meter. And this default value is applicable to all new houses, but then a lot of the contractors use 0.4 or 0.2 to get better results in their energy performance coefficients calculations.
Are there any things to look out for when you're doing a test like this?
Yeah, there are a lot actually. So there's a whole preparation in terms of the building, but there's also limitation in terms of the weather. So you couldn't really do this test if it's very windy, because it would fluctuate our readings too much, for instance. And then, yeah, there's a lot of other factors as well that are at play.
How would we go on about finding the leaks?
So there are a few different options. One of them is to do a smoke test. So with the smoke test, you pressurize the building and you release some smoke on the inside of the building. And by seeing where it comes out, you can basically figure out where the smoke is leaving the building. So this is one of the options. There are other methods as well, such as thermography, heat imaging, and each option has their own pros and cons. In terms of helping a client understand what's happening, then a smoke test is very clear as well. Because if you release it on the inside and they see it come out from the outside, then it's pretty evident that this is the only, well, that's the path that the smoke is taken outside of, through the building envelope.
Mm-hmm. Yeah, with the thermography, you can see it more visual, the size and the area of the gaps.
Yeah, correct. The only issue with thermography, and that's the advantage and disadvantage as well, is that you see a lot more, and because of that, you need a lot more understanding of what you're seeing. So if you see an anomaly, it could be warmer or colder spot. It could be an air leak, but it could also be missing insulation. It could be that there is a heating or a radiator behind it, or you see a reflection of the sun, for instance, or it could be a wet spot, or someone leaned against the wall. There's a lot of different options. And that's why thermography requires a lot more interpretation compared to using smoke to see where the leaks are.